Hamiltonian path is a path that passes through every vertex in a graph once, and only once. It doesn't have to include every edge. Unfortunately, there's no good way to determine whether a Hamiltonian path exists or not, other than by trying to find one, so it becomes a trial and error process. Let's look at this graph and see if there's a Hamiltonian path. I'm going to start at vertex F. I can go to G, A, B, C, D, and E. And in that process, I've gone through every single vertex, but I left a few edges unattended. Alternatively, I could go from F to G, to E to D, to C to B and A. And I've still hit every vertex in the graph. So to write that out, a Hamiltonian path in this case, F, G, E, D, C, B, A. And that's the way we would write out the path. A Hamiltonian circuit is a Hamiltonian path that begins and ends at the same vertex. So the first vertex is repeated as the last vertex. But no other vertex can be repeated, and every other vertex has to be included. Let's take a look at this graph and see if we can find a Hamiltonian circuit in it. Going to start at F, go to G, to E, to D, to C, to B, to A, and finally back to F. So I have managed to complete the requirements. I've touched every single vertex once, and I returned to the original vertex where I started at F. So the Hamiltonian circuit in this case is F, G, E, D, C, B, A, and then back to F. Try the next one on your own, and then come back to see the solution. Identify the Hamiltonian path in the graph below. So it's fairly arbitrary where you start, but you're going to have to get a little bit of experience in figuring out what works best. In this case, I'm going to start at E, go to D, up to B, over to C, and over to A. So this path has hit every single vertex, which makes it a Hamiltonian path. Question 13. Identify a Hamiltonian circuit in the graph below. Remember, for a Hamiltonian circuit, we have to start and end at the same vertex and go through every vertex only once, except for the last vertex where we end up. There's also no good way of determining whether a Hamiltonian path exists or not, and no good way, therefore, determining whether there's a Hamiltonian circuit. So it's basically a trial and error process. I'm going to start at A, go to B, to D, C. Oh, that doesn't work because I've ended up back where I started, but I haven't hit E yet. Try a different path. Nope, same problem. In this case, I've got a Hamiltonian path because I've touched every vertex, but I haven't ended up back where I started at vertex B. Now it looks like we've achieved success. So I started at B, went to E, D, C, A, and B, and that gives me a Hamiltonian circuit.